Hey everybody, so we're going to walk through the examples in the guided notes in this video. In class we will have gone over the information that's at the top of this page, and we will be using that as we go along through each of the examples. So the first thing we need to know before we start is in order to write the equation of a line, you need a point and the slope of the line. So in each of these examples we're going to start by getting a point and a slope. Alright, so let's look at example number 1. We're going to write the equation of a line passing through these 2 points in slope-intercept form. All right, so we need a slope. We don't have that. And you know to find the slope between 2 points, it's change in y over change in x. So my y's are 4 and 3, and my x's are -5 and 2. And remember, you must keep them in the same order, top and bottom. So I get 1 over -7, which is -1/7. So now I have the slope, so I'm going to mark that so I can keep up with it. It's -1/7. Now I need a point. Now I have 2 points here as an option, and either one of these will work. So I'm going to choose 2, 3. Now that I have the slope and the point, I'm going to ignore the problem itself and just focus on the form that I want to get it into. So in this problem, we want it in slope-intercept form. So slope-intercept form is y equals mx plus b, where m is the slope, b is the y-intercept. So we know the slope, it's -1/7, but we don't know the y-intercept. Remember, a y-intercept is a point where the x value is 0. This point we have isn't a y-intercept. So what I'm going to do is say, I don't know what my b is, but I do know that if the point 2, 3 is going to be on this line, when I plug 3 in for y and 2 in for x, it should make the equation work. So I'm going to take this equation, and I'm going to plug in 3 for y and 2 for the x. This leaves me an equation I can then solve for b, multiplying those things together. And then I want to move my -2/7 to the other side. And then these are adding fractions, so I need a common denominator. 3 is 21/7, so that gives me 23/7. Now, my equation was y equals mx plus b, right? And I know my m was -1/7. Now I know my b, which was 23/7. So it's -1/7 x plus 23/7. And that would be my slope-intercept form. Now there is another way of doing this, and I'll show you that way as well, just in case you like it better. You really could choose to do this by the way I just did in the top, or by this method. Now, point-slope form, which is y minus y1 equals m times x minus x1, often gets a bum rap because you don't work with it very much, but it's very easy to write an equation in. If I know my slope, -1/7, and I know a point, 2, 3, I can plug my -1/7 in for x, and my 2 in for x1, and my 3 in for y1, and that's in point-slope form. Now, this question asks for slope-intercept. Well, if I wanted to go from point-slope to slope-intercept, I can distribute the -1/7. Oops, stopped operating there. And then -1/7 times -2 is +2/7. And then I can get y by itself, because in y equals mx plus b form, y is by itself. So I can add 3 to both sides. And you notice here we got this 2/7 plus 3 that we can combine, just like we did when we were solving for b. Same math, just coming from different origins. So I'd get 23/7 here. So either way you can do this. You can jump straight into slope-intercept form, plug in the slope for m, the point for x and y, solve for b, and then write the equation. Or you can drop it in a point-slope form first, simplify by distributing, and then get the y by itself. All right, let's look at the problem over to the right. This time we're writing an equation of a line between 2 points in standard form. So whenever you're writing something in standard form, never go directly into standard form In this problem, it would be possible to, but it would be kind of painful to do so. There are certain situations in which you're given information that you wouldn't be able to. But basically what you want to do here is instead start with slope-intercept, then change to standard. All right, so again, always need a point and a slope. So first thing I'm going to do is find my slope, change in y over change in x. I think that gives me 4 over -6, which is -2/3. My point could be either 1,7 or 5,3. I think I'll choose, let's choose the -1,7 this time. Now I'm going to go directly into slope-intercept form. My m is -2/3. I don't know my b, but I know the point on my graph is -1, 7. So -2/3 times -1 is 2/3. And then I'll need to subtract 2/3 from both sides. That's 6 1/3, which by the way is 19/3. It's a little bit easier to use in proper fractions here. I'll show you why in a few minutes. And then that means my equation in slope-intercept form was y equals the slope x plus the y-intercept. So this is in slope-intercept form. To get this into standard form, we're going to do two things. We're going to get rid of fractions. So we have a denominator of 3 everywhere here, so I want to get rid of that 3 by multiplying this equation by 3 on both sides. 3 times y is 3y, 3 times -2/3 x is -2x, 3 times 19/3 is 19. And then I need to move the x and the y to the same side. So I'm going to add 2x to both sides and make sure my x term is first. Now, some teachers make a big deal about this a term being positive or negative. I don't. The only reason that standard form is really around is because it helps us when we're working with systems of equations, and for that purpose, it doesn't matter if the a is a positive or negative. But if you want to make it positive, like it is right now, perfectly fine. But this is now in standard form. All right, let's flash over to the second page. Whoops. Now, this time we're asked to find the equation of a line parallel to a given line which passes through a point. So again, we want point and slope. So the point is given to us. The slope, we're told the line is parallel to this one, and that line is in slope-intercept form. Parallel means same slope. So the slope of my line then is going to be 2/3. And now I can follow the process I just did on the last problem to write this in standard form. I recommend pausing the video, trying it on your own, and then checking your answer when you come back. All right, I'm going to do the work while I pause my action. There's the work to get it into slope-intercept form, just in case you want to check your work up to this point. And now I'm going to pause again and finish out the standard form. And that's what this would look like. Now again, if your Algebra 1 teacher really stressed to you that the a term must be positive, that's fine. You could actually write this as 2x minus 3y equals +3 by multiplying both sides by -1. Either one of these answers would be acceptable for me. All right. So flashing over to this problem. Again, we want point and slope. And this time we're writing it in point slope form. So this is going to be a shorter problem once we get the information. So my point is 7, 1. Now, this equation is in standard form. And if I wanted to get the slope out of a standard form equation, we're going to get this into slope-intercept form. So to do that, I want to get the y by itself. So I'm going to start with 3x minus 5y equals 7. I'm going to subtract 3x from both sides. I'm going to divide everything by -5. That's going to give me 3/5 x minus 7/5. So the slope of this line is 3/5, but I wanted perpendicular slope. And remember, perpendicular is opposite sign, flip the fraction. So that means my perpendicular slope is -5/3. So now I want to write this in point slope form, which is this. And point slope form is super nice because once you know the slope, and once you know a point, you simply plug those things in where they go. The y value of the point was 1, the slope was -5/3, and the x value of the point was 7. And that would be the equation in point slope form. Now, finding x and y-intercepts. So you may recall in the beginning of class, we talked about x and y-intercepts and that they are places where the line crosses the x and y axis. And that every x-intercept has to have a y value of 0, and every y-intercept has to have an x value of 0. So if we're given the equation of a line and we want to know what the intercepts are, the way we do that is if we want an x-intercept, we're going to let y equal 0 and solve for x. So I'm going to show that. You get 3x plus 5 times 0 equals 9. So 3x equals 9, x equals 3. Now, when you write the x-intercept, please write it as a coordinate. We plugged in 0 for y, we got back 3 for x. The coordinate of that point is 3, 0. Now, I'm going to find the y-intercept now. The y-intercept, you let x equal 0 and solve for y. So if I were to let x equal 0, this part would be 3 times 0, which is 0. So I basically have 5y equals 9. So y is 9 divided by 5, which is 1.8. I could write 9/5. I could write 1 4/5. All of those are fine. And remember, I plugged in 0 for x and got 1.8 for y. So the coordinate of that point is 0, 1.8. By the way, I do want you to write these as points with the 0 values, because a lot of times when I ask people to get x-intercept and y-intercept, they'll get the numbers and then they'll put them together as points, like 3, 1.8. I don't want you to make that mistake. All right, last problem. This is probably the most complicated of the bunch. So we have a line that we've been given, and that's this line here. And we're looking for the equation of a line that's perpendicular to that, and it shares that line's x-intercept. All right, so we're going to deal with the perpendicular part first. So my slope is, oops, wrong color, make that red, is perpendicular to this, and this line is in point slope form, and the slope appears right here. It's 2/5. So it needs to be perpendicular to a slope of 2/5, which means the slope is -5/2, opposite reciprocal. Now, this line also that we're trying to come up with also has the same x-intercept as this equation. So how do we find x-intercepts? Well, we did that in the last problem. We let y equal 0 and solve for x. So I'm going to plug in 0 for my y, and I'm going to solve for x. Now, 0 minus 3 is -3. I'm going to distribute this 2/5. Now, I could go ahead and subtract 2/5 from both sides and then divide by 2/5, but a lot of people get confused when they're working with fractions. So here's a suggestion. At this stage, get rid of the fractions. do what we did for standard form. Multiply both sides by 5. This makes it a lot easier to just solve for x. Again, that's negative 8.5. I wanted this in slope-intercept form. Now I have a point, which was the x-intercept. Again, remember we plugged in 0 for y. And a slope. And once I've got that, I'm just going to ignore the problem because I have the information I need. I just need to get it in slope-intercept form. So y equals, my slope was negative 5/2 x plus b. The point I'm plugging in is 0, negative 8.5. Now for my purposes, because I'm not using a calculator, negative 8.5 is negative 17/2. When I multiply those two fractions together, I'm going to get 85 over 4. And then I have to get b by itself. So it's going to be negative 85/4. And then my equation is y equals mx plus the b, which is the same thing as subtracting 85/4. There we go. If you need extra review in these problems, the summer work videos for 56 through 59 are much the same kind of problem.